Welcome back. In this course so far we have learned three adjectives very specific to thermodynamics. The first one was adiabatic. We know what it means. The second one was reversible. We have defined it very meticulously. The third one was isentropic. Isentropic means at the same entropy. An isentropic pair of states means two states of a system which have the same entropy. An isentropic line means in the state space a locus, any state on that will have the same entropy, similar to an isobaric line or an isothermal line. It is possible that many of us are confused over this, over these three. What is the distinctness between these three? I will now make an attempt to reduce or possibly remove that confusion. Let us write the expression which we have derived linking ds to dsp. Let me write it as ds is dq by t plus dsp. This is change in entropy. This is related to heat flow and this is entropy produced. Notice that this tells us that a change in entropy is partly related to heat flow and partly is produced. Okay. Now let us make a sort of a table, but here columns are important, rows are unimportant. Do not have to give any meaning to the row. Let us begin with the middle column, that pertaining to dq by t. We know that dq by t for some processes could be 0. Such a process we will call an adiabatic process. It is possible that during a process the system absorbs heat, in which case this could be greater than 0. We do not have any special thermodynamic name for it, but if a system absorbs it, maybe one could call it perhaps an endothermic process. It is possible that during a process the system rejects heat, in which case dq will be less than 0 and dq by t will also be less than 0. Again, you may call such a process an exothermic process, but in thermodynamics we do not use these terms quite often, endothermic and exothermic. So you notice that when it comes to dq by t term, that term can be 0, it can be positive, it can be negative. If it is 0, then we will call that process an adiabatic process. Now let us come to the left column, the one pertaining to change in entropy. It is possible that for a process the change in entropy is 0. In that case we may call that process an isentropic process. It is possible that for a process the change in entropy could be greater than 0, or it is possible that the change in entropy is less than 0. Nothing special about it. It all depends on what is the final state and what is the initial state. During our illustrations and exercises we will see a number of such examples. So when it comes to change in entropy, we know that all three options are possible. It could be 0, it could be positive, it could be negative. Entropy produced is special. It is possible that it is 0, in which case ds is dq by t, and that is possible only for a reversible process. So if dsp is 0, we will call that process reversible. It is possible that it is greater than 0. If it is greater than 0, ds is greater than dq by t, it is an irreversible process. What about the third option? Can it be less than 0? No, less than 0 is not possible, because in that case it would be an impossible process. The second law tells us that this is just not possible. Okay, so here we just have two options. Okay. Now what is the consequence of this? Notice that it is possible for a process to be isentropic. That only means this term is 0, the first term is 0 on the left hand side. But on the right hand side, these two terms need not individually be 0. It is possible that dq by t is less than 0, but dsp is greater than 0. Equal and opposite in sign, so your ds is 0. That means you can have an isentropic process which is neither adiabatic nor reversible. Similarly, consider a process which is adiabatic. It only means that dq by t is 0. It does not mean that dsp and ds are 0. It is possible that dq by t is 0, but dsp is positive and so is ds. And in that case we have a process which is adiabatic, but which is neither isentropic nor reversible. The third option is also possible. Let us consider a situation where the entropy produced is 0. Well, this term is 0, dsp is 0. That only means that ds is equal to dq by t. Neither of them need be 0. It is possible that a system absorbs it during a reversible process, in which case ds will be positive, the entropy will increase. It is possible that during a reversible process the system rejects it, in which case the change in entropy will be negative, entropy will reduce. But we have an illustration, or we have a number of illustrations where we have a reversible process which is neither isentropic nor adiabatic. So we should realize that the three adjectives, isentropic, adiabatic and reversible, these three mean three different things. We must appreciate their independent definitions. They are related to each other, but not very strongly. If you say a process is isentropic, that does not mean that it is adiabatic, that does not mean that it is reversible. So an isentropic process need not be adiabatic, need not be reversible. Similarly, an adiabatic process need not be isentropic, need not be reversible, and a reversible process need not be adiabatic, need not be isentropic. So these three are three independent entities in that sense. However, going back to our relation, ds is related to dq plus dsp. So if you decide to make any two of these three terms 0, the third will have to be 0. For example, if you make ds 0 and dq 0, dsp has to be 0. If you make dq 0 and dsp also 0, that means ds also is 0. So what does it mean? That although these three are three sort of independent characteristics, you decide that you have two of them, then the third automatically comes. So if you have a process which is isentropic and adiabatic, it will be reversible, you have no choice. Similarly, if a process is isentropic and reversible, it has to be adiabatic, there is no choice. And a process which is adiabatic and reversible must be isentropic, there is no choice. So either you must have these adjectives each one individually, then the other two need not follow. But if you take any two, the third automatically comes. So here you have a funny choice, you pick up any one, the other two will stay there, they will not follow you. But if you pick up two, all three will then come together. So you either have just one or all three. The choice of 2 out of 3 does not exist. Thank you.